Welcome back to another video. In today's video, we're going to run through question 1 of the 2020 VCAA Maths Methods exam. So that's the non-calc exam. Question 1's out of 3 marks, and the average for part A was 0.9, and for part B, which was out of 2, was 1.4. So generally answered pretty well, but still not everyone's answering it at 100%. So let's run through this question. So the question is states, let y equal x squared times sine x, and we want to find dy dx, so obviously the derivative of that. So let's just quickly write out the question again. X squared sine x. So hopefully you guys can identify straight away that we're expected to use the product rule, because we've essentially got 2 different functions here. We've got the x squared and we've got the sine x. So the form of the product rule that I like to remember and teach to my students, it is included in the formula sheet, but vu times plus of. So, taking each of these with the derivative, and it's the summation of both of them. So derivative of x squared times sine x plus x squared times the derivative of sine x. So it can be also useful, especially in more complicated functions, to separately write out what these expressions are. So just let u equal to that x squared there, and v equal to sine x, and then we can work out the derivatives individually. So we know x squared becomes 2x, and sine x will become cosine of x. So then it's just a matter of substituting in our numbers again. So u x squared times v dash, which is cosine of x, plus sine x times 2x. So I'll just put 2x sine x. Done. Straightforward, simple. Didn't even need that much room. Question B, we've got evaluate f dash when x is equal to 1, where f spans from r to r. The function f of x is equal to the exponential to the power of x squared minus x plus 3. So this is the function here. F of x is equal to e to the x squared minus x plus 3. And the form that I like to remember for exponentials and their derivatives is the following. So if we have, in general, this function y here, and we want to find dy dx, similar to what we have for this specific example, well, we know that's just going to be the derivative of the power by what's already there, essentially. So applying that to this specific example, we have the derivative of the power, which is a quadratic, so we know derivative of x squared minus x plus 3 would be 2x minus 1, and then what we've already got there. So e to the power of x squared minus x plus 3, that bit all stays the same, and that's the derivative. The next part is evaluating at a particular point. So we want to evaluate when x is equal to 1. So this should be a simple substitution, just letting x equal to 1. So we're going to have 2, I'll insert an extra bracket there, write it out in full. 1 squared minus 1 plus 3. We can see that 2 times 1 minus 1 is just 1, so we can essentially ignore that. We've then got 1 squared minus 1, can ignore that, that becomes 0. So what we're left with is e to the power of 3. Nice and simple. The most common mistake with this one is when we're taking the derivative, a lot of people tend to omit the brackets here. So you can always be more conservative by adding in additional brackets, even if they're not required. But it's, if you miss the brackets here, then all of a sudden you've got 2x minus this exponential term, you're going to end up with a different answer. So we'll leave it there. Hopefully you guys got some benefit out of this video. If you've got any specific questions, you'd like me to cover, either leave them in the comments section below, or feel free to email me at yourmathquestions@gmail.com. Thanks guys, see you in the next one.